Okay, so right now we're looking at Campi Flegrei, looking at earthquakes. Not too many earthquakes. However, uplift is a different story. Right here, as you can see, significant uplift. In fact, it's gotten a lot more significant over the last couple of years. When I first started covering Campi Flegrei back in 2020, uplift was pretty significant, but the rate of uplift has only accelerated since then. Look at this rate right here. Station RIT is having significant uplift. This all started back in 2012. And it's because of this right here that they actually put Campi Flegrei under a state of unrest. They put back in 2012, ever since 2012, Campi Flegrei has been at alert level yellow. And despite this pause and uplift, and even brief subsidence, they kept it at alert level yellow, and it just continued. In fact, there's been major changes to Campi Flegrei, especially to their monthly. That's the monthly right here. Mensili means monthly. Monthly bulletin for Campi Flegrei. So let's look at it right now. This is for April. So we're just waiting for it to load. Okay, it's still loading. It's just taking its time. I'll show a lot more diagrams, including the accumulated energy, earthquake energy, compared to now and to the 1982 to 1984 crisis. So right now, this is earthquake energy. It's just to 200%. Number of events, numero eventi. So numero eventi has reached its highest level in recorded history since the 1982 uplift episode. So this is the highest level recorded at Campi Flegrei since the early 1980s. So this is the highest state of unrest in at least the last 30 years. Actually 40 years. This is not the 2010s anymore. This is now 2023. Most of the quakes at Campi Flegrei have been at a very shallow altitude, very shallow depth, between 1 and 2 kilometers. This is where most of the quakes occur, between 1 and 2 kilometers right here. With some quakes going deeper, between 2 and 3 kilometers. and a few isolated going out to 4 and 5 kilometers. I believe this is due to the influx of magma, and this is where your magma chamber is, at a depth between just under a kilometer, going down to about 3 kilometers. So it's a shallow magma chamber, and it looks pretty big. I mean, that's about 2,000 meters of magma that's pooling right underneath the caldera. And then you have another larger magma reservoir that is feeding both Campi Flegrei and Vesuvius. And when I went to Vesuvius, most of the magma erupted from the 1944 eruption was basaltic. There's a lot of scoria there. In fact, most of the magma erupted from Campi Flegrei and Vesuvius is of a similar composition, which is basalt, trachyte, and phonolite. Trachyte is a high silica rock, which is high silica magma, which is similar in composition to high silica andesite and higher silica spectrum to dacite. However, trachyte is basically more similar to dacite in terms of silica composition. Slightly below silica composition would be trachyandesite. But if you don't have if it's different from andesite, it will be basalt, phonolite, trachyte, and then rhyolite. And from my experience, from my understanding, I did find some very white welded ash, which could be rhyolitic or could be trachyte. But from how white it was, it's very likely rhyolitic. In fact, the Pozzolana ash, which has been erupted during the third Phlegraean period over the last 5,000 years, is very likely trachytic to rhyolitic, trachyte to rhyolite composition ash, which means that there's definitely a lot of pressure building in the caldera. The 1538 eruption did not occur in the center of the caldera and actually occurred on the outer edge of the caldera by a town called Mincino. That's in fact where Pliny the Elder and Pliny the Younger lived, near Messina. They're more outside of the caldera, and the melts there are more basaltic. However, deep inside the caldera, there's a lot of silica likely leaching into the crust. And there's also a lot of highly rhyolitic and highly trachytic ash, which, if combining with the magma chamber, that could actually form highly explosive eruption. The caprock, the ash caprock, the Pozzolana, acts as a block for the magma. It causes pressure to build and build and build and build and build. Though you might have had a tiny release from the 1538 eruption, on average, Campi Flegrei has a VEI5 or VEI6 eruption every 5 or 10,000 years. And the last such eruption was the Monte Spino eruption, which was about 3,000 years ago. Or actually about 5,000 years ago. Because I forgot, it was just before Roman time. So it was about 4,000 years ago. The next eruption at Campi Flegrei could be a major one. I'm not saying it will be, but it could be. I don't want to say, oh, it's going to be, it's going to be a super eruption, because it very well might not be. In fact, this is the distribution of depth. Most of your earthquakes, almost all of them, are occurring at relatively shallow depths and between 1 and 3 kilometers in depth. This is where the majority of your earthquakes are occurring. At the present moment, I don't see any immediate danger at the volcano. Nothing that screams it's going to erupt imminently. Nothing at the moment yet. Of course, that can change. We are having a big increase of earthquakes. But the seismic crisis of the 1980s 82 to 84 was much more significant than what we're seeing right now at the moment. In fact, the Monte Nuovo eruption was here, but the center of the caldera is in this area, so a little bit distant. In fact, you see this crater, that's the Monte Spino eruption. It's a Monte Spino caldera, and you see a lot of other little little craters right here. There's a crater. There's a craters here, here, and then you have the greater caldera itself right here. Then you also have another caldera here. See how there's an increase in elevation here, then it suddenly goes down? That's indicative of that there was once possibly a stratovolcano here or a series of lava domes, or it could also be from the pyroclastic flow deposits too. In fact, just about 3,000 years ago, most of this was underwater. Before the Roman Empire, after the massive eruption, the last caldera-forming eruption, all of this was underwater. At one point, the water almost extended up to about here. See how flat the land is here? Most of this is underwater. And you can see the uplift rate is still going up at a rate of 15 plus or minus 3 millimeters a month. So between 12 and 18 millimeters a month, because minus 3 plus 3. So it could be as low as 12 or as high as 18 millimeters a month, depending on how high it was for that month. But look how it's been going. Look at the uplift rate from 2000. And this is centimeters. This is not millimeters. These are centimeters now. In 1 year, we've gotten more than 10 centimeters of uplift now. This is definitely getting much more significant. The RITE location is having significant uplift. See? Oh, this is English. Oh, look at that. This is actually English. Surface tilt meter, borehole tilt meter, and digital borehole tilt meter. Okay. Let's see if there's anything else. Okay, that's uplift. Let's see magmatic gases. That's what I'm really trying to find. This is Pisciarelli right here. This is where I was. This is Solfatara. Temperature in Celsius. In fact, it's actually going down. It's a good sign. You want to see a decrease in temperatures. But it could also be a bad thing as magmas, if you're having less emissions of fumaroles, if fumaroles are getting cooler, yet you're having uplift, that could be a sign that the volcano is pressurizing. It could also be bad. But over pressurizes, you could actually get an eruption sooner rather than later. The more volcano degases, you might think, oh, it's a bad thing because it's venting, but that could actually be what's preventing an eruption. So this right here, these are volcanic gases, and look at that. They're continuing to go up and up and up and up. See right here, you had an increase. You had a big increase, but not like we're having right now. We're having a far larger increase. But where are your records? This is looking at carbon dioxide and hydrogen. So this is your CO2 and hydrogen emissions. So the fact that you're emitting at such a high level now, it's very concerning. CO2 Look at that, see? Even in the 80s, there was nothing significant. Wow. This is major, guys. This is definitely major. Volcanic gases are definitely increasing now. Keep in mind, these are years. 2022, 2024, so, yeah. There were two peaks, 2007 and then 2017. It almost looks like almost 10 years apart. Almost, but not quite. So yeah, this is definitely serious. It's not an immediate threat, but it's definitely something to be concerned about. Yeah, I'm going to send this to Geology Hub. Yeah, CO2 emissions are definitely very high right now. Again, earthquakes a month. Increases. So we're seeing increase. Right now we're seeing increasing seismic activity, uplift, and CO2 emissions from the volcano. We're seeing three increases that are signifying that an eruption is around the corner. However, what we're not seeing is we're not seeing harmonic tremor. We have not seen any of harmonic tremors. Whenever earthquakes that occur at Campi Flegrei are what is known as volcanic tectonic earthquakes, which are caused by the rock fracturing. Normally, that would be because of magma moving through the cracks. However, the earthquakes at Campi Flegrei are not quite caused by the movement of magma per se. But the stress is put on regional faults caused by the uplift. What is causing the uplift? It's a factor of things. Magma, building inside the caldera, inside the magma chamber, but also increasing gas pressure. And it's that increasing gas pressure that has scientists concerned. Too much increasing gas pressure could overload the volcanic system and lead to an eruption. Will that eruption be a caldera forming eruption, or will it be smaller like what we saw in 1538? That remains to be seen. Anyway, I will do more tomorrow. In fact, there's a new update coming just a few hours. I'm going to bed right now. Thank you for watching. Good night. I'll make another update tomorrow. And I'll also make videos on a severe weather threat, on a possible weather event for later in the week. Thank you for watching, and I'm glad to be back. My channel is back. I'm no longer terminated. That's why I was gone for 2 years. My group home staff got my channel terminated because they did something they weren't supposed to do. Apparently, you see how I'm having this live stream running here? Apparently, I wasn't able to end the live stream, and I forgot to close out studio. That's what caused the whole fiasco to happen. I'm not going to say what happened. That's for another day. But Campi Flegrei is, in fact, having more activity that needs to be watched. But is a supervolcano eruption going to happen? No. Absolutely not. Almost all the eruptions in Campi Flegrei for the last 10,000 years, 12,000 years, while large, were not supervolcanic eruptions. The one 40,000 years ago was a low-end super eruption on a VEI 7 area. VEI 7 is not, when you hit VEI 7, you're not automatically at a super eruption. To be classified as a super eruption, you need to have at least 250 cubic kilometers. Campi Flegrei during its Campanian Ingerbright eruption emitted at least 400 cubic kilometers, making it a super eruption. However, the Neapolitan Yellow Tuff eruption was a high-end VEI 6 to low-end VEI 7, emitting between 90 and 110 cubic kilometers. So even if it did hit 110, it was not a supervolcanic eruption. While the last eruption did form a caldera, it was not large enough to be classified as a super eruption. Is Campi Flegrei a so-called supervolcano? Low-end, yes. Campi Flegrei is a low-end supervolcano. By low end, it means that it does not hit the VI8 category. And its next eruption will most likely be a cinder cone forming eruption, or maybe even a phreatic eruption, as Geology Hub stated. Most likely, you're going to have an eruption sometime this century. In the next 50, 60 years, it's most likely going to erupt. Because leading up to the 1538 eruption, there was a period of uplift that lasted several decades. There was a brief pause in uplift for a few years, and then there was a sudden peak of uplift, not at its current location that it's experiencing now, but at the site of the Monte Nuovo eruption. But originally, the uplift was centered at the center of the caldera where RITE is located right now. It was in Pozzuoli, but then it was the northwest side of Pozzuoli that had the highest uplift. We could have another repeat of that, or worst case scenario, this is the absolute worst case scenario and the least likely scenario to happen, is a high-end VEI5 to low-end VEI6 eruption. That's the least likely scenario. Most likely is something from range of 1538 to maybe a Vulcanian low-end, maybe a subplinian eruption. Basically like what happened at Shivlich. Basically, or at the Soufriere Hills volcano at St. Vincent and the Grenadines. At the not Soufriere Hills, at the La Soufriere volcano. La Soufriere. Maybe that kind of eruption, most likely. And that's kind of more like going a little bit higher. Somewhere in the middle is slightly larger than 1538, but not as large as La Soufriere. Basically like what Sakurajima experiences. Anyway, thank you again. Good night, everybody. And when I say, if that eruption does happen, that, high-end VI3, low-end VI4, it's probably a couple decades away at the moment. Of course, that could change, but from what I'm seeing right now, it's not imminent. Thank you for watching. And I would recommend going and visiting, Pozzuoli. It's a beautiful city. You might smell a little sulfur, but, eventually you'll get used to it, and it's not an unhealthy amount, it's just a little bit. And most of the sulfur is coming from the Solfatara crater, which, it's named for sulfur, and Pisciarelli site. Anyway, good night, everybody.